All right, what we're doing here is we're going over the homework on page 201 of your book. This is about conservation of momentum. And so here we're looking at it, and problem number 1, we have an astronaut who gets stranded in space, and he is going to throw his oxygen tank away in order to get back to the space shuttle. And what they tell us, let's get down here where we're writing. What they tell us is that the astronaut has a mass of 63 kilograms and initially is not moving. So we're using conservation of momentum here, which means the initial momentum of our astronaut is going to be 63 kilograms times 0 meters per second for not moving. Then the astronaut, since he's not moving, his spare oxygen tank is also not moving, which is 10 kilograms. And it is also not moving. So combined total initial momentum is going to be 0. Now that's going to equal the other side of the equation, where we have the after he throws his oxygen tank away from the shuttle. So the astronaut, 63 kilograms, times unknown final velocity is going to equal, I'm sorry, not equal. We're going to add that to the oxygen tank, 10 kilograms, times 12 meters per second. And so we're going to see here that the initial momentum adds up to 0. These two momenta will also add up to 0. So 0 is going to equal 63 kilograms times VF plus multiply 120 kilogram meters per second. Now we're going to have to do a little subtraction. We're going to subtract 120 over 120 kilogram meters per second is equal to 63 kilograms times V final. And then to solve it, we're going to do a little dividing. So get out the calculator here. 120 divided by 63. And we're told that he's got a velocity of 1.9. Now, I didn't put the negative into my calculator, but we know that negative is still there. So when we divide by the 63, whoops, move it down a little, sorry. Divide by the 63, we learn that 1.9 meters per second in the negative direction. That negative direction is highly significant because we're saying that he throws it, the tank, away in the positive direction of 12. And so to conserve momentum, the small, fast thing goes in the positive direction, and the big, slow thing goes in the negative direction, so that they can add up to 0. So this is problem number 1 in the homework on 201.